So convex mirrors and concave lenses diverge, spread the light out from F, and a concave mirror and a convex lens converge, bring light together. And so the lens that we're going to look at is the double concave that looks like that, and the convex lens is the double convex that looks like that. And so when we're looking at the picture, instead of having C, because you can use a lens on either side, right? You can have the light going in either way in the lens. Instead of having C, we have F and 2F. And you can have the ray coming from either side. So if I have a light ray coming from left to right into a concave lens, it spreads out like it's coming from F. And if I have two parallel light rays coming from the left to the center, and I always go right to the center of the lens, it then bends as if it's going to F. So what we have here is, how do we make these, what do we do to make these pictures? And again, these are the things that's going to be on the long answer, and then the image characteristics: larger, smaller, real, virtual, erect, or upside down. So draw the beam of light, and then here is the easiest, straight through the center, and the one is parallel and through F. And it's got to be, remember we said big F. Okay, so I go right to the center in parallel, and it's kind of the same idea as before. When I had stuff outside here, when it was a mirror, the image would be in here and it would be smaller. It's the same idea, but it's just going to be on the other side. I have it outside there, so the image is going to be over here somewhere and smaller. In between F and 2F. This is, so, in there and right to the middle, and then through F. And now the other one goes straight through the middle. So let's see if I can do that one. Okay, straight through the middle. And now where these two cross, right here where they cross, is the top of my image, just like the top was here. And so it's going to be there. So the image is going to be real because we've had solid lines crossing. And we know Riverside, right? Riverside. So we know it's real and it's inverted. Well, obviously it's inverted. And we said anything that's between the F2F or FC is always going to be smaller. And now this next one, same diagram. So again, you're going to have one of these, and again, these should all be big F's. And it's really important because it's a typo here. Okay, so in parallel, and through F. And then the next one is straight through the center. And this should be right here at 2F. And these two, it's just like being at the center, should be the exact same size. So this is real, inverted, and anything at 2F or at the C is same size. And then this next one, it's exactly the same thing. So here's the thing. One of these three will be one of the three lens questions. Because those three are all exactly the same. It's draw parallel straight through and you get it either like in between F and 2F, smaller, right at F, the same size. Here, the difference is, okay, now my object is between F and 2F, so I know my image is going to be out here, and it's going to be bigger. So I go in parallel and through F, O. And then straight through the middle. Across here. So my image is real, inverted, larger. So again, one of these three is one of the three lens questions. One mark for the diagram, one mark for the three correct words. This next one is the second of the three lenses. So this one of the three. So what do I do here? I go in parallel and through F. Okay, then I go straight through the middle. And, oh, this one isn't, sorry, that one's at F. Just like at F with the mirror, even if I dot these back, these are all parallel lines, and there'll be no image. So just like when it's at F in the mirror, at F in a lens, they're parallel, nothing, you don't see anything. So that one, sorry, won't be one of them. One of these three, and then this next one, this one, will be one of them. And so what do? Again, I go in parallel, so I draw this first, and through F. So there's my first picture. And then I go straight through the center with this other line right here, line number 2. And obviously 1 and 2 don't cross, but if I back up 1 and I see where the light ray is coming from 2, I can get them to cross in behind. This is a magnifying glass. And because one of the light rays is dotted, one or both, it's going to be virtual. We also know it's a rect, so it's going to be virtual, and it's larger. This is a magnifying lens. So again, the second one goes straight through the middle, and then I can extend that. And that's how I get and so that one will be one of the ones on the test, the second lens one, and here's the third lens one. This one is, again, a little tricky because people, forget how to do this one. Concave lens, the ray bends out. So I draw it in parallel and as if it were coming from F. It bends as if it were coming from F. The other ray goes straight through the middle, and so I go straight through the middle, and they cross in front. One of the lines is dotted. Obviously where they cross the top is it's right side up, so it's virtual, erect, and smaller. So there's the other diagram that's on the long answer. So now you know there's 3 mirrors, there's 3 lenses. the diagrams and the words. It's meant for you to get 12 out of 12 if you practice these. If you don't, you're gonna end up thinking, I forget how this goes, and that 12 isn't gonna be there to help you on your multiple choice. It's gonna be there to kind of make you sad and wish you did more practicing. The lens equations are exactly the same. 1 over f equals 1 over di plus 1 over dou, and m is equal high ho and negative di dou. And the negative in the di dou formula is just saying it's upside down or inverted. And the negative in the di 1 over f formula is there because it's virtual. And remember to be careful of the signs. So what you have to remember on a test, you always write right away at the beginning, concave mirror. And again, I said all I remember is this one. That's the first one we did. I remember concave mirror, oh yeah, the F was in front and it's positive. And everything else in that square box around it is the opposite thing. So if a concave mirror F is positive, a convex mirror F is negative. If a concave mirror F is positive, a concave lens F is negative. So once you write that down, then when you go to do your question, here I've got this, okay, here's an object that's this tall. So I know that if that's the height, it's the height of the object, and it's this far, this is the distance of the object. Now, it says it's a convex lens, so I go over here and go convex lens positive. I don't try and remember that. I just go to my little chart and go, oh yeah, positive, so I put that in. Because if I try and remember it in my head, I know I'm going to get them mixed up, because mirror, lens, convex, concave, it's just like whatever. Here's my little chart, oh yeah, it's positive. Find the distance the image is from a lens. So, the distance the image is from the lens, okay, so 1 over f equals 1 over di plus 1 over dou. So I have 1 over 7.5 equals 1 over di plus 1 over 15. I change those to decimal equivalents, so 1 divided by 7.5 is 0.133 equals 1 over di plus 0. Subtract that over to the other side, and I get 0.667 equals 1 over di. So then I know that di, remember this is over 1, so di over 1 equals 1 over 0.667, which is 15. And 0 centimeters. So distance image from the lens is 15. Now, I can look right away and say, oh, I kind of know that if the focal point is at 7.5, double that is 15, then I know that I'm at the C or the 2F. So I'm going to be on the other side at the C or the 2F. What's the size of the image? I can do the calculation, but I know that the height of the image has got to be 2.5 because I know it's the same size, but I can go high ho over negative di dou. And I put in pi over 2.5 equals 15, negative 15 over 15. So I get HI equals negative 2.5. this means it's upside down, right? It's flipped over, which the size of the image, the characteristics, or we could say the size could mean the magnification is 1. The characteristics of the image, we know that it's real because DI is positive. We know that it's inverted because of this negative here, also because it's real, and we know it's the same size because we figured it out. Okay, what about this one? It's in front of a concave lens. So I go to my little chart, concave lens. Oh, F is negative. So I go here and it says concave lens. So here's my height of the object. Here's my distance of the object. It's concave, so this makes this negative. So I have 1 over F, 1 over F, so it equals 1 over di plus 1 over dou. So what I have here is I have negative 1 over 5 equals 1 over di plus 1 over 9. So here I go, this is negative 0.20. .1111. Now, I subtract 0.11111 from both sides. And I get negative 0.3111 equals 1 over di. Therefore, di equals .2 and negative 3.2 centimeters. So this means it's virtual. And the size of the image, sometimes it's magnification, just Dido over Hi-Ho. Size, I'm thinking let's do the height. So I'm going to go Hi-Ho over negative di dou. So I have here high over 4 equals negative. Now this negative here stays there, negative 3.2. So negative, negative. Negative, negative means it's going to be a positive, which means it's going to be right side up. Thank you, Mikey. So then dou is 9. So now when I solve for height, I'm going to get 3.2 times 4 divided by 9, and I get 1.4. High equals 1.4 centimeters. And it's positive, so that means, because this is positive, that means it's erect. Makes sense because here, virtual goes with erect. Virtual and erect, Riverside. And we can see that because the height is littler, we know it's smaller. So the characteristics are it's virtual, erect, and smaller. And you can kind of deduce that in the sense of it's a concave lens, and the focal length is 5, so it's placed at 9. So let's go back and look at where that would be. It's a concave lens here. Focal length is, let's say, 5. That would be 10, so it's placed in between. Makes sense. And so I get an image that is right side up, it's smaller, and it's virtual. So that picture made sense with the numbers they gave us, so you can kind of double check that way. Okay, so important to practice those diagrams, because if you think by just watching me do it that you can just do it, you will be surprised at like how how similar they look. So your homework is to draw the diagrams of all of these, and notice where it says characteristics, you need to write down the 3 words, right? And that's again practice for the 3 diagrams that you need to know. Then the question 2, so question 1 through to 12. So 1 to 12 is your homework for here. And